So good afternoon, guys. Thank you so much for joining us today. We are continuing our Tuesdays at 2 sessions. And today the guest is Evenlite, and we'll be talking about their new PWII 2 inverter. Here with me today, I have the Kyle Keller, who is the manager of sales support for Evenlite, and Darren Grande, who is the New York Northern Eastern Regional for Evenlite. As a reminder, there is a Q&A box or a chat box. Feel free to ask questions as we go. Our session today will be approximately 20 minutes, and then we'll address all the questions at the end. And I guess without further ado, let's just get on it.
Go ahead, Darren.
Oh, yeah, everyone, I want to thank everyone for stopping in here, spending a couple minutes with us. My name is Darren Grande, Eastern Regional Manager with Evenlite. And Kyle Keller is going to be presenting today with the on the PWII. With further ado, I'll let you jump into it, Kyle, and get going.
Great.
All right. Good afternoon. Thank you for being here today. My name is Kyle Keller. I'm the manager of sales support for Evenlite, and we will be talking about the PWII. I want to be very clear about the materials that I'm presenting today. So the materials that I'm presenting today, everything that I'm presenting today can be found directly on the Evenlite website. Simply go to evenlite.com, click on products, and you will go to central inverters. Once you're in central inverters, go to the center section, the PWII. And then all of the materials that I'll be presenting today are going to be right here in this download section. So let's get started on the specification sheet, and let's talk a little bit about what the PWII is exactly. So this is the exact same sheet that is available to you on the website. I am simply bringing this up into Adobe Acrobat, so it's a little bit easier for everybody to see. So you just saw the video on the PWII, and I think that you may have seen in that video that it is a mini dimming inverter, and that's exactly what we are going to be talking about today. The PWII is our newest product. It is the mini dimming inverter. The PWII is based off of the PW platform. So for those of you that are familiar with our PW12 or PW25, we already have those out in the market. This inverter was built directly off of that platform. Now, when we were building this platform, we had three things in mind. The first thing in mind was do not increase the price, and we did not. So the PWII is the same great price that the original PW line was as well. But we wanted to concentrate on a couple things. We wanted to make sure that we were using that PW base product as a springboard for brand new and exciting features. So first off, we wanted to make sure that we had the specifiers, the reps, the specifiers, the engineers in mind when specifying this product. We wanted to make it easy to specify. But then on the back end of that, we wanted to make sure that it was easy for people to install and use. So I'm going to concentrate on those things today. Right here is the spec sheet. The spec sheet is 3 pages long. The first page is aimed specifically for anybody that wants general information about the PWII. The second page is the more engineering related information or data. And then the third page is strictly aimed at application. So let's dive right into the first page. I'm going to be bouncing back and forth between quick specs and features. And some of those are directly related. The first thing I want to talk about is everything that makes this thing easy to use in the field. So we are talking about a 125 or a 250 watt inverter that has dimming as an option built into it. So
sorry, on my screen, it's a little blurry. I don't know, Darwin, if you see it blurry as well. Maybe you need to zoom in a little bit. I see PW mini inverter, and then it's the whole page is a little blurry. It's hard to read.
Yeah, that's good.
It's better. It's just one more. Click one more time on that.
One more time.
Yeah, I think it's better. It's better now. Okay, this is much better. Awesome.
Okay, so getting back to what I was saying before, the PWII has two things that we aimed at, and that was easy to use in the field and easy to use for the specifier or rep. So the first thing is the field selectable voltage. It is 120/277 field selectable. So you no longer have to order a specific inverter for voltage. It will do either 120 or 277, and it switches over in approximately 3 seconds in the field. So it's extremely easy for a contractor to adjust. The second thing that I want to talk about is the outputs of the inverter. So this inverter has actually 4 outputs. The first one is a normally on output, but the other 3 outputs are going to be field configurable, and you can configure those as either normally on, normally off, or switch type outputs. So in other words, you're going to have 1 normally on and 3 more outputs that would be configurable. Each one of those configurable outputs is configurable independently of the other one. So you could maybe have 1 normally on, 1 normally off, 1 switched, and then another 1 normally off. That's just one example of what you can do with this inverter. So again, that is something that is configurable in the field. So you do not have to worry if something on the job changes. We can totally adapt to that change in the field. The other thing that I want to talk about field selectability has to do with transfer time. And why transfer time is important is because of the controls that are used to control the lights in the area. So many time controls require what's called a dead time or a downtime. And that really is just the time that it takes between going from normal mode to emergency mode. Some controls take as little as 50 milliseconds. Other controls can take upwards of 2 seconds. So we have with the PWII dimming inverter a field selectable option, or I'm sorry, it's standard, but you have 3 different options as to what you can change that to in the field. So you can change the transfer time anywhere from 50 milliseconds up to 2 milliseconds. So again, another user selectable or field selectable option on this inverter. Now, I keep mentioning that it's a dimming inverter, and it is. So many times what you would have to do to make sure that you are in compliance with UL 924 code, especially if you have dimming controls, is you would normally specify some sort of energy backup or either an inverter or a battery pack or a generator. But then in order to bypass around the controls, you would need to put in a UL 924 transfer device. This is required by code to bypass controls. And basically what that does is it allows you to allow the lights to go to the emergency level, bypassing the control or any setting that control was set to. So that's the old way of doing things. But with this new inverter, you no longer need the transfer devices. And that's because the transfer devices are built directly into the PWII itself. So with the PWII dimming interface, it's the FD option, those 3 configurable outputs, you also have the ability to do dimming on those 3 outputs. We will accommodate either Dolly, 0 to 10 volt, Lutron ecosystem, or any of those other 2-wire low voltage standards that are out there on the market. Each one of these configurable outputs then would have a configurable dimmed output, And that dimmed output can be anywhere from 20 all the way up to 100%. I'm going to talk later about exactly why that's important and where this comes in, because you can actually hook up 375 watts to these little inverters, which make these inverters very, very versatile for applications. So again, just jumping through a few other things. So this is a 90-minute inverter. Of course, we can get it to run up to 2 hours, depending on what load is connected to it. It has an overload capability of 110%, but there's something that's industry leading in this inverter, and that is crest factor. Now, crest factor is one of those things that generally gets overlooked or ignored, but here's why it shouldn't. Crest factor is really the ratio between inrush and then normal operating power. That is the easiest explanation that I could give you as to what crest factor is. So essentially, inrush is where you are going to have your maximum potential for the demand on the output side, and then the regular running power is kind of the maintained level of the lights. The difference between those two is what's called crest factor. The higher the crest factor, the better an inverter can accommodate large amounts of inrush. That's typical of today's LED drivers. So we have an industry leading 10x crest factor on our 125. And what that really means is that in this 125 watt inverter, we can withstand 1,250 watts of inrush, which is a very, very large number. I do not think you could find a 125 watt light or group of lights that would provide that type of inrush. So we are very accommodating to battle the overloads or any type of inrush problem. Speaking of overloads and inrush, advanced startup, charger, and inverter diagnostics standard on our inverters. We also have self-testing and self-diagnostics as a standard feature as well, which is going to adhere to Life Safety 101 code. So, okay, I mentioned a bunch of different things about this inverter, and this really is just the data page on repeating some of the information I gave to you already, but then there's more detailed information on this page, and this is really aimed at engineers. But the approvals and the certs are UL 924, NFPA 101, NFPA 70, NEC code. It's a NEMA enclosure, and it's NEMA 410 rated for up to 375 watts. Here is what the inverter looks like with the front page, with the front cover off of it. I did mention before about switching between 120 and 277 volts in the field, and it only takes 3 seconds. It's literally unclipping this connector here and then clipping it in down here. So it is literally that easy. Now, I mentioned before about this being a dimming inverter and the outputs. So you can see here that you have the one normally on output, and then you have 3 other outputs. These are the 3 outputs that are configurable in the field for either normally off, normally on, or switched. Those 3 outputs are tied in with the dimmable outputs as well. So if you want output 1 to be at 20%, you can do that. And then you could also have output 2 at a different percentage, say 40%. And then you could have output 3 at a completely different percentage. Maybe you want that one at 80%. So again, field adjustable, very easy to use. This would be standard mount, either above the ceiling, in a closet. You can really mount this anywhere. It does have T-bar mounts, so that is another option. So let's talk about the application of this inverter. Here is a very basic diagram of how this inverter will play into maybe one zone of lighting. So you have your power coming into the inverter, you have your power going up to your dimmer, and then you have your dimmer that's connected directly to the normal lights. However, we're going to bring that dimmer feed, that dimmed hot, we're going to bring that into, or the switched hot off of your dimmer, excuse me, because that's low voltage dimming. You're going to bring the switched hot into your inverter and then out of your inverter to the emergency lights. One thing that you do not see in this diagram is you do not see, or there is an absence of a UL924 transfer device. Again, that's purposeful because you no longer need the transfer devices for this particular inverter. So that is the basics of how this inverter gets connected, but let's talk more about the application. Now, I mentioned a bunch of different things and I was kind of spitting a lot of information out there, but I want to be very clear that you can absolutely hook up to 375 watts on this inverter. So 125 watt inverter, you can connect 375 watts to it. So if you can connect 375 watts to it, why is it not a 375 watt dimmer? Why is it 125 watt? It really comes down to the modes that this inverter operates in. So it operates in two separate modes. It operates in normal mode and it operates in emergency mode. In normal mode, the inverter is going to pass power directly through itself. So that means that the power coming into it will get passed directly to the lights connected to the output side. So if you have, say, emergency lights that function as normal lights as well, it can absolutely pass power directly from the input side to the output side for a maximum of 375 watts. So here's a diagram of what I'm talking about. Elena, I'm going to have to zoom out because I got to get a lot on the screen here.
Yeah, that's fine. And just a heads up, we are 18 minutes in.
Okay, so here is the inverter, and you have the three outputs of the inverter. You have three separate rooms in this diagram. Room 1 is just the same as room 2, as the same as room 3 as far as the lighting fixtures go. So these are all the same 2x2 fixtures, except we declared 5 of those as emergency fixtures. Those 5 fixtures are 25 watts each. 5 times 25, if I had the lights on full bright, that would be 125 watts of load. So again, room 2 and room 3 are exactly the same for a total of 375 watts. But here's where the rating of the inverter comes in. In emergency mode, I can still power those fixtures, but those fixtures are now going to be at a dimmed level. And that's because the inverter is actually supplying the power. How you get there is you have those 5 fixtures that are 25 watts. And in room 1, I'm going to set those to 20%. So if I take the 5 times 25 times 20%, that's roughly 25 watts. I do the same thing for room 3. And then room 2, I'm going to set to 40% because it's a little bit different layout. And that's going to give me a total of 100 watts. That 100 watts is under the 125 watt rating. So therefore, the inverter can supply power to 125 watts of output in emergency mode and pass through 375 watts. One thing that I do want to mention about this, you don't have to have emergency lights at 100%. You just need to reach the foot candle level that's required for proper egress out of an area. This is where dimming can come in, so that way you don't have to run those fixtures at 100%. This also saves you a lot of money because in this scenario here, with the 375 watts of load, typically, if it was a standard regular inverter, you would have had to specify a 450 or 500 watt inverter. In this scenario, you're specifying 125 watt inverter, and you don't also have to purchase those UL924 transfer devices. All of it's built directly into the inverter. Elena, that's all I have at this time. I'd be more than happy to open the floor to questions.
That's actually perfect. 20 minutes in. Do you guys have any questions? So far, we've got none. And we'll be following up with the video that Kyle showed in the beginning and the cut sheet for the inverter. But feel free to ask any questions if you have. And as the questions coming in, let's give it a few seconds. Okay, so any chance for a DMX control option?
No, it does not. It does not accommodate DMX. The only way that you could accommodate DMX within this scenario would be to simply strip out one of the conductors of the DMX and run that through on the 2-wire input. But we don't have an actual DMX connection.
Great question. And the only question as of right now. So we'll hang out for a few minutes. Okay, here's another question. Is this only 0 to 10 dimming? The diagram on page 1 looks like standard downlight. Is that passing through standard dimming as well? So when EM would just turn those fixtures to 100%.
So this would be for low voltage dimming, any low voltage dimming. So it could be 0 to 10 volt. It could be Dolly. It could be Lutron ecosystem, or any of those other proprietary two conductor low volt signals out there. This inverter does not do high line voltage dimming by default, but there are certainly applications that there are ways to do it. Absolutely. You could use this for line voltage dimming, and I could show you real quick the diagram of that, but it might not be the way that you would think that it would do it. So it's easier just for me to show you. So here's the wiring diagram. Hold on a second. Let's see where that is. So here is an example of doing line voltage dimming. So essentially what you would do in this scenario is you would connect your fixture to either output 1, 2, or 3. And then you would also take your normally on output and run that through your dimmer, and then tie your dimmer also into the hot for that fixture. So you're double feeding your fixture. So yes, you absolutely could do line voltage dimming, but the dimmable part of that, where you turn it from 20 to 100%, that doesn't control line voltage dimming. So yes, you could do line voltage dimming, just not dimming that line voltage dimming. It would be done by the control. But in that scenario, then the light would absolutely go to 100%.
Okay, yeah, that was my next question. If the dimmer is not digital and it's actually a paddle, do you guys override it and bring the light output to 100% for the line voltage?
Yeah, in that scenario that I just showed you, yep, that would bring it to 100%. Yeah, because you're bypassing around the dimmer. Yes.
Gotcha. Great question. Awesome. If you don't have any more questions, we'll hang out for a minute or two just to address any other ones. But if you don't, thank you so much for joining us. I know it was a little longer than typical Tuesdays at 2 session, but I think it was very knowledgeable and very useful for everybody. We'll follow up with more information, and we'll probably do another session on the Evenlite inverters in a week or two. We'll keep you guys posted. Thank you so much for joining. And Kyle,
thanks, guys.
Let's just hang out for a few seconds to see if there's.
Yeah, I'll stick on anyway. I wanted to chat with you.